Hi everyone, welcome to Creative Coders Toolkit, where we have a very special episode today. We're going to be building our very first abstraction. We're going to make a metronome object that we're able to call back on in future sketches. So let's hop right into Pure Data. So let's get our metronome functioning, and then we can look into what it would take to turn it into an abstraction. And we'll get into kind of what that is a little bit later. So first, we are going to start with what is called a metro object. And basically what metro does is you toggle it to start and stop. And when it's toggled on, it just outputs a single bang at the millisecond interval that you either send it in this top right corner or a number that you instantiate it with in milliseconds. So every 100 milliseconds, this metro will send a bang out. Let's make it 200 so it's a little maybe easier to see. But if we put a bang under this metro, hop out of edit mode and start it, every 200 milliseconds, we see that it is outputting a bang there. So 200 milliseconds, so 1/5 of a second, so 5 times every second, this metro is sending a bang out as long as this top part is toggled. And so we can use this to make it create an audible metronome. There's just a couple of things we need to get it to do that. And so let's go ahead. Control E is what gets us in and out of that edit mode so that we can actually run the sketch versus make changes to the sketch. Let's up this to 1,000. So this is the same as 1 beat, 1 bang per second, or the equivalent of 60 BPM, which is fairly slow. We can see what that does look like in terms of bangs. We can even keep that going, and we'll just go ahead and turn that off. Okay, so what do we need in order to hear this? So what we're going to end up using, we've got a couple of options for different sounds that we can hear as like the click of a metronome. And then we need something to turn on and off that sound. And so there's kind of 2 component pieces that we need here. So let's start with the one that makes sound. First things first, let's throw a DAC down here so that we have something to listen to. And let's throw a multiplication object so that we can sort of temper how loud this thing is getting. So on the DAC object here, left and right is just your left and right output for a stereo signal. You can have mono DACs where it's just the one, or you can have, if you've got like an 8-channel audio interface, you can have as many outputs as your interface has for a DAC. And you can actually even instantiate this with a number of channels. That might not be the right way to do it. You're limited to the number of channels in your audio settings here. That makes sense. Okay, but so here is just our like volume stage for what we're going to end up hearing later. The metronome itself, the sound that we're going to use is, and we're going to try a couple, but for right now, we're just going to make a sine wave. And the object that makes a sine wave is just this OSC object here, and we'll make it go at 600 hertz. And so we can actually hear what this sounds like just straight. If we turn this on, There we go. We can go and delete that. DSP back off just means that we can keep working without having to worry about like a bunch of noise coming in. So that's what our just our oscillator sounds like, our oscillator sound object. And now we need a way to, instead of just having it play all the time, we need it to ramp up and then ramp back down very quickly so that it makes like a rhythmic sound. And the way that we're going to achieve that is with an object called vline. I am going to be perfectly honest with you. I am really bad at line objects. For whatever reason, it's the one object that I just cannot seem to wrap my head around. vline, I have a little bit of a better understanding of the way that you tell it information. And so I'm going to explain how you can program vline to behave in certain ways. And we'll be able to use this number box to sort of like witness that happening. Actually, so vline is one that has this tilde at the end, which means that it is operating at audio rate, which means that the way that we can read what's happening from it is with a couple more objects. We need what's called a snapshot object. Oh. Is that not what the object is called? Okay, if we go into the help here, oh, it's snapshot with a tilde. See, help files, very helpful. Okay, so we need a snapshot tilde object. And then we feed this from it. And then we can also feed it this metro object, and we'll put a toggle in front of it. This just lets us basically watch the output that's coming from vline into this snapshot object, and then we can actually witness what is happening. You can turn on that metro. All right, so now with this vline, when we send it a message, it sends information out of vline corresponding to this message that we tell it. And so what we're doing is we're programming directions for what to do. And for example, what we can do is we can tell it, I want you to go to the value 1 in 1,000 milliseconds. And then I want you to go back down to 0. And I want that to take 1,000 milliseconds at the 1,000 millisecond mark. And so if I click this, it's going to go to 1 in a second, and then it's going to return back down to 0 in a second, starting at 1 second. It's like a cumulative. So you're telling it how long you want it to take, and you're also telling it at what point you want it to start. It's really convoluted, and we'll play with a couple more scenarios, and maybe then it'll be easier to see sort of what vline does. So if I click this, that super didn't work, did it? Does DSP need to be on? DSP needs to be on for any object with a tilde. Anything that's operating at audio rate means that the audio has to be turned on. Okay. So now, when we click this, it takes 1,000 milliseconds or 1 second to ramp up to 1. And then we want it to ramp back down to 0. We want it to take 1,000 milliseconds, and it's going to start at the 1,000 millisecond mark. I'm going to try another example of this, and maybe we'll be able to see a little bit more of like how it works. So if we add another destination, so this middle one, let's have it ramp down to 0.5. And then for the last destination, we'll have it go all the way down to the 0. Okay, so for example, what if... So it ramps up to 1, and it takes a second to do so. And then it slides down to 0.5. And it takes 500 milliseconds. So what we should see... here, 1 second. And then we want it to ramp down to 0. And I want it to take 2 seconds, so 2,000 milliseconds. By the time we get to 3,000 total. So let's see what this looks like. Okay, so what I saw was that it took 1,000 milliseconds to ramp up to 1. It immediately started ramping down to 0.5 because we were already at this 1,000 millisecond mark, and it took half a second to do so. And then it waited there for, I believe, 1 second, and then it spent 2 seconds ramping down to 0. So let's take a look at it again. Yeah, so what we're saying with these last numbers, this destination, the accumulative millisecond number is that yeah, that's really tricky. Like, even the help file doesn't do a great job of explaining exactly what line is doing, what VLine specifically is doing, and like how the elapsed delay numbers work. That's going to be someone else's tutorial that you're going to have to watch. I'm so bad at the line objects. I literally end up having to just like fiddle with them until I get them to behave in a way that works with the sketch. For me, it really is just trial and error, which like so much of this for me is. I wish that I could be more helpful with this particular object, but I am just so bad at getting them to cooperate. All I know is that for this metronome object, we want it to ramp open to 1, 1 being our like audio volume multiplier in 20 milliseconds. And then we want it to ramp back down to 0. We want it to take 20 milliseconds, and we want it to start after 20 milliseconds have elapsed. And that is what this gives us. So if we click this, it happens too fast to see. But that's what it is doing. And so because we have this multiplication number mixed with this sound source combining in this multiplication like amplifier box, and then it's being turned down, and then it's hitting our audio output down here at the bottom. And so what's going to happen when we plug this metro into here is that when this metronome, or when this metro object sends a bang out once a second, it's going to open up this audio multiplier. It's going to let this audio through for 20 milliseconds, and it's going to ramp back down to 0. So it's going to open it up and then close it, clamp it back down in like 20 millisecond bursts. And this is what that's going to sound like. Our DSP is on. Okay. Yeah. So now we just have a little clicky sound at 60 BPM. We can get a different sounding click if we change the frequency of our sine wave oscillator. We can raise it up to 800 hertz. So a little higher click. Other changes we can make, we can have it be like that white noise object that we had in our other session. So that it's just this V-line object is just opening and closing, opening and clamping down on this white noise object at the same rate that this Metro object is sending bangs out, which we can still visually see here. If that white noise is a little jarring for you, let's try a pink noise metronome. It's a little more subtle. Still has that kind of like crispy top end, but it's a lot less harsh. And again, we can always go back to our sine wave oscillator sound if you kind of want it to have more of a pitch, like an associated pitch. Okay, so that's all well and good. We've got a functioning metronome. Let's even change the rate that the metronome is clicking at. So we can use this number box to change the milliseconds for how quickly this metronome is clicking away. So now we're at 971 milliseconds. The smaller this number goes, the faster the metronome is going to click because it's based on milliseconds instead of something that we're more familiar with, like something like BPM, which more musicians would be familiar with. So if we bring this number down, gets a little bit quicker and a little bit quicker. There we go. It's going to hit a point where this 20 millisecond number is not fast enough to open and close, and it'll just sound like it stays open the whole time because it's just not able to process fast enough. So you can play with lowering these amounts if you have to, but at this point, you know, only if you need something that clicks this quickly would you even, or faster even, would you actually need to change the rate that line opens and closes back up again. Okay, so let's turn that off. Okay, so like I said, here we have a functioning musical metronome. You know, one other really important thing, musicians are not going to know what millisecond they need their metronome to click at. They're going to know what BPM their song is. And so we need to figure out a way to go from a BPM number to a millisecond number. So let's do a little bit of math and figure out what kind of calculation that looks like. Okay, so we are designing a metronome. We know that 60 BPM equals 60 beats per minute, which is the equivalent of 1 beat per second. And we know that 1 second is 1,000 milliseconds. So that's where our 1,000 milliseconds it is the equivalent of 60 BPM, because 1 beat per second is 1,000 milliseconds. And so this is our baseline. So we can use this relationship to calculate any other BPM into milliseconds by knowing this. Call it a ratio, call it a relationship, call it whatever you want. Okay, so now we can use that ratio of 60 BPM to 1,000 milliseconds and figure out how many milliseconds any given BPM is going to be. So, for example, we know that we are going to have 60 BPM over whatever our new target BPM is going to be. So let's, for example, say that we're going to try to go up to 120 BPM. And this is equal to 1 beat over 1,000 milliseconds. That's our 60 BPM ratio that we had from before. And so we have 1/2 equals 1 over 1,000. And so we end up with this ending up over there. So we have 1,000 over 2. We end up with a millisecond amount of 500. So 500 milliseconds gives us 120 beats per minute. And so we can use this ratio to figure out how to go from any BPM to any millisecond number. So let's hop back over to pure data. Okay, so back in our current sketch of this metronome object, what we can do is create an expression. And in this expression, we know that we're going to have 60 over. So $ is pure data's way of saying this is a placeholder number for a variable that we have. So for example, $F1 is going to be the floating point number 1 coming into this expression box. And it's how we can control the flow of information going into this expression box, and then it outputs the number that comes out of this like mathematical expression. And so 60 over $F1, and then times our 1,000 millisecond number. And so we can put a number box up here. And then when we start inputting a BPM number, so 120 is going to give us that 500 millisecond number. And so this is beats per minute, goes through this expression box, and then it comes out as a millisecond number. Okay, so now we have a metronome that accepts beats per minute as a number input. we can choose whatever noise, whether it's a sine wave oscillator, pink noise, or white noise, for the actual clicky sound. And then we've got an output stage here. And that brings us to the whole idea of abstractions. So let's say that you're in a new patch, further down the line. Let's go ahead and save this, actually. We'll save this as, so here's our PD folder. We are going to make, I guess we can't make a folder from here. So let's go find our pure data folder. We're going to make a new folder called sketches, which is where you can save full projects or whatever. So now let's save this there. It's called, let's not call it, we'll call it Metro Test. Because that's all we were doing is figuring out how to build a metronome. And we have a functioning one. So we can even click it on and then put in our BPM values and have it actually be the correct value. So musically, if you had something that was marked at a certain BPM in sheet music or whatever, here you have a way to make a metronome that will click along at that rate. But like I was saying earlier, what if, you come along in the future, you've got a brand new sketch and you're like, oh man, I really want a metronome, but I just want to be able, I don't want to have to build a brand new one in my new session just to have this thing that I've already designed it once. I already know that I can, but I just want a simpler solution. I just want a simpler thing that I can just drag and drop and you want to be able to use it like an object. And so that's what an abstraction is just this, more or less complex, already created thing that you are going to repeat over and over. It might have some different parameters. It might have some different settings that you can change. But fundamentally, it is this thing that already exists, and you just want to be able to use it as an object over and over. And so we're going to build that metronome abstraction. And so if we come into Documents, into our PD folder, we're going to make another new folder, and we're going to call it Abstraction with one N. So we've got our externals, we've got our abstractions. We'll make it with the S, because everything else is plural in here, and sketches. So we are going to this new pure data session. We're going to go into not sketches. We're going to go into abstractions and name it metronome. And we're going to save it. So here we have the beginning of our metronome abstraction. When you're building an abstraction, one thing that you are going to have is, with any object, you have these boxes on top, boxes below. It's the inputs and the outputs of any pure data object. And when you're making an abstraction, those things are called inlets and outlets. So up top here, we are going to have an inlet. We're actually going to have two. And the way that pure data handles this is that it will automatically look at whatever the leftmost inlet is, and that's the one that ends up in the top left. And then every other inlet is in order from left to right. And so it'll automatically figure out, that's the order that the inlets and the outlets go, is their physical, how far they are from the left side of the screen. So from left to right, that's which box is going to be on the object. And then we are only going to need one single outlet So there's actually, there's two ways that we can handle this. We could have it with an audio outlet so that you then have to plug it into audio, or we could have it have no outlets at all and have all of the audio handled inside of the object. The reason I hesitate to do it that way is you can put a DAC object inside of an abstracted object, but then you don't have volume control unless you build another inlet and actually have like a slider or a number value for how loud you want the metronome to click. So having it outlet the sound gives you a little bit more control over routing it and where you want to route it to. To each their own. I can see pros and cons of both. For this example, let's go ahead and give it the outlet just so that we can hook it up to our DAC ourselves later on. So we're going to go ahead and I'm going to leave Metro Test open because we're going to be rebuilding this object from tools that we have up here already completed. So there's our outlet down there. Here's our inlets up here. This left inlet, we're expecting this toggle object. And then the right inlet, we're expecting this math that turns our BPM number into a millisecond number. And so what we can do is underneath this inlet is where our metro object is going to live, that toggle going right into there. And this inlet over here is going to go through this exact expression from above, which is just that 60 over $F1 times 1,000. And I don't think I needed to put any of those spaces in there, so that's all we need. To go into the right side of there. That looks great. And then same thing as before, this message box of 120, 0, 20, 20. This is as good a time as any to talk about just generally trying to keep your sketches a little clean, nice straight edges, objects kind of staying close together if you don't need a lot of branching paths. This is our amplifier stage that the V-line is feeding into. And then we have to make an executive decision. What kind of sound are we going to make our metronome out of? Personally, I love pink noise. I love pink noise metronomes. I just love the stuff. So then we have all of our sounds coming through here. We've got our metronome object basically all created, and then we've got the audio coming out through this outlet. And so this is the abstracted version of the metronome that we built up here. Okay, so now we've saved this metronome object, and we can even close that, and we can close this. And now, if we create a brand new, unsaved sketch up here, and now we're going to put an instance of our metronome object. Oh, it couldn't create it. And the reason why is because we haven't linked that abstraction folder to be imported on Pure Data opening. So let's close this. We won't save it. Now, if we come over to path, we're going to add a new path, which is our abstractions folder. And we're going to apply. So now, if we close and relaunch Pure Data, start up a new sketch, and try to instantiate a metronome object, it loads. So if we put a toggle, so here's another good lesson. So the difference between bang and toggle, if you click bang, it sends a single bang through the line, and it either sends the message through once or just pushes information through just one time, and then it resets itself. Toggle, you can click on, and it's just that single one on, single one off. One on, one off. And different objects will request either a bang or a toggle to work properly. Just read the help file and it'll tell you, like certain music players want a toggle to remain playing, and then you toggle it off and that 0 when it's done. Because that's what a toggle sends, is ones and zeros. Whereas a bang sends literally a bang through the line. So it's just different objects want to see either a bang through the line or they want to see the ones and zeros from the toggle object. That Metro is one that wants to see the ones and zeros. Okay, so we have our toggle for the left side of Metronome, and we have a number box for the right side. And now we just need to create an output stage. And we can let it be a little bit louder. You should experiment for yourself how loud you want stuff to hit this output stage. One of the next abstractions that I'll build is actually a sort of a built-in visual abstraction with a volume slider that is its own sort of built-in like DAC output object. That sounds really confusing. We'll build it and then it'll make a lot more sense. So for right now, just knowing that most of the time, anything that you build, you'll probably want to turn down before it hits your sound card's output. Because a lot of stuff in this application can be really, really loud. And so now we hop out of edit mode so that we can set a BPM there. And then when we click this on, we get nothing because DSP is still not on. So we turn on DSP. Now we're getting our metronome click. That is such an important reminder that like it's there's so many different moving parts. Let me turn this off. There are so many different moving parts that determine when something works and when something doesn't work. The trick is just to figure out what's the simplest explanation for why I'm not getting sound right now. Did I wire something wrong? Even before that, is the audio even turned on? Are my headphones plugged in? Is my volume knob turned up? Is DSP turned on? Did I mess up something in the volume stage here? Is everything wired properly? Am I sending numbers to the right places? There are so many different things that can go wrong that can explain why something's misbehaving, why something's not doing the thing you expect, why sound isn't happening, why you're getting errors, why you're getting, you look at the console and you see it come up with like the object couldn't be created. It's like, oh, then that there's some sort of import problem. It's like troubleshooting is such a huge part of like coding in general, but also just like creative coding and coding in pure data. Because that's what you're doing is, some of this can get really complicated really fast. Best advice, fail early. Like start testing stuff really early. Like test the functionality of everything that you add and make sure that it's behaving in an expected way. You want every piece that you add to do the thing that you expect it to. So like add a thing and test it. Add another thing and then test everything together. Test it on its own. Test it with the rest of the thing that you're building. But like always troubleshooting, always testing stuff as you go. There is one last piece of functionality that would be that's always really nice to add to any abstraction. That thing I did right there, because this is an abstracted object, there's a whole sketch inside of this. When you're not in edit mode and you just click the box, it opens the sketch of the abstraction. You can hop into edit mode and make changes to it and save it. So we can, come in here, change this to a white noise generator instead of a pink noise one, hop over here, and then click it on. So one thing that is always really nice to be able to do is for this object to actually instantiate it. So it's, let's see, did I discard or save changes? I saved them. Okay. I'm actually really curious now. If I create another instance and open it, it's still pink. So now, I guess, anytime you open one of these from within the sketch here, you're making changes to the specific one unless you do it properly. So boom, change it to noise, and then save it. And so now that I've actually saved it, it saves the copy of the abstraction to the folder. And now when you create a new metronome object, it's actually saved. Okay. Good to learn. So now, one thing that's really nice, a really nice piece of functionality, especially for an object like this, is let's say, let's delete this object, put brand new metronome object, hook up this number box, hook up this toggle, hook this up to the sound, and hit go. Sorry about that. Why did that happen? Why was our object not clicking at any particular rate? And the reason why is that when we created this metro object didn't have a number to start with. We had not sent it this 96. We hooked it up, but we didn't send a number through that cable. And so this metronome didn't have anything wasn't clicking at any rate because it wasn't given a rate to click at. And so we want to be able to, from the moment something gets instantiated, you want it to have values that you can actually start using right away, or at the very least have ones built into it, so that it doesn't misbehave from the moment that it's created. And so, for example, if we wanted to create this metronome object and type in a value BPM that we want it to instantiate at. So let's say metronome 120. We have to actually tell it where to pull that 120 from and what to do with it. And so this object is just going to be $1. That is the name of the first parameter of this instantiated object. There's the name, and then there's the first parameter, and that's this $1. And then if we put this object called load bang, it just means that when an object is instantiated, it sends a single bang through the cable, through the sketch. And so we create the object, it grabs that 120 value or whatever the first number here is, and it saves it in this box. And then when it gets created, it load bangs through here, goes through the expression, and then gets loaded into that metro. So we're going to save the object here. And we're even going to get rid of that one just so you can see that it's actually working properly. So we're going to build a metronome object, and we're going to have it start at 80 beats per minute. We set up this toggle, and we set up this audio output. And then we can start it. And now we're clicking along at 80 BPM. And obviously, we can still put a number box here and change that number. Because if we pop into here, this, let me turn that off because that's loud. This number here, this number 1, it's going to remember the number that the object got instantiated with. But it's only going to bang the once. Only a single bang the moment that the object is created will send a number through and set this metro to that number. Otherwise, that number gets replaced by anything that we send through this right inlet. So you still have the flexibility to change the BPM that you want, but when you create the object, let's say you know the BPM that you're going to want for the whole time, you can just create it with that number and not even worry about sending something through this right inlet. If you need to change it, you can, though. You have the flexibility to be able to do that. But yeah, so here is our first, fully fledged abstracted object. Is there anything else that needs to be added to it? I'm pretty satisfied with this. I can't think of any functionality that I would necessarily feel like I need. If you can think of something that you'd like to add to the metronome, obviously give it a try. Like, tell me what you tried. I want to hear what kind of functionality you wish it had. What kind of other parameters you'd wish it had. Maybe you want to change the sound of the click. Maybe you want to, reduce some of the complexity of the inlets. Maybe you want to completely get rid of the flexibility of this right inlet. You just want to, instantiate it with a certain number. Go nuts. Your abstractions are yours. You get to name them. You get to change the inlets and outlets. You get to control everything you want about how you functionally use them. And there are these abstractions should be the types of objects that you can just drag and drop into future projects, know exactly how they work, and just get a lot of use out of them. Because the whole point is that they should be saving you time. They should be objects that you're going to end up using over and over, that you don't want to have to keep recreating. If you find yourself piecing together a lot of these really similar objects, find a way to streamline the whole process. If you keep, making envelope objects, if you keep using VU meters, if you keep trying to design, I've already a couple of times made these, specialized DACs with audio getting turned down before it hits the output. My next abstraction will be something that streamlines that even more. So if you have something that you keep redoing over and over again, make an abstraction. It'll save you so much time and it'll make your sketches look a lot cleaner. Anyway, that's the point of abstractions. And we're going to find lots of opportunities to use and create some really cool abstractions further down the road and make some really cool looking sketches. Thanks for joining me on this one, and I'll see you in the next one.